Hello everyone, today we're going to show you how to calculate volume using disk method. Have you ever wondered how to calculate the volume of a curved three-dimensional object like this one, this vase? Well, we could using integral calculus. So this function right here can resemble this three-dimensional object by rotating it around the x-axis. At each individual point on this function, that could resemble the radius of a cross-section. So rotating this around the x-axis, there's going to be a circular cross-section because at various points there is a circle that's being revolved around the x-axis. So at different points of this function is a different radius of cross-section. So in order to calculate the volume of this vase right here, we have to take the sum of the infinitely small cross-sections like this one and over the interval of which the function is stretched out. Allow these Legos right here to resemble the cross-sections of this vase. You are slicing the vase into numerous segments, and by integrating all the individual pieces, you can find the volume of the three-dimensional shape that is added together. As you can see, once you put all the pieces together, they resemble a three-dimensional shape like the vase, which is the goal here by integrating.
Alright, so we're going to find the volume of the 3D shape with y equals radical x rotated around the x-axis. So in other words, what we're going to do is we're going to take the function, and when we rotate it, we can actually see it forms a circle, and radical x, right here, radical x turns into the radius. So actually what we can do in order to find the volume, first we can find the area by saying that area is equal to pi r squared, and we said that the radius is equal to square root x, so we can say area is equal to pi square root x squared, or a is equal to pi x. And now Cam will integrate.
You can find the volume of this 3D rotated shape by taking the integral of the cross-sectional area. So the cross-sectional area is equal to pi x. So the volume equals the integral from 0 to 4 of pi x dx. So a constant multiple rule tells us that since pi is a constant, we can take it outside of the integral. So we can rewrite this as v equals pi times the integral from 0 to 4 of x dx. So the fundamental theorem of calculus tells us that when you're evaluating a definite integral, you have to take the antiderivative, which for the antiderivative of x equals 1/2 x squared. So what you want to do now is v equals pi times 1/2 x squared evaluated from 0 to 4. So now substitute 4 and 0 into x, you get v equals pi times 1/2 4 squared minus 1/2 0 squared. And that gets v equals 8 pi